Haricharan, we'll have to share the link or at least put a message.
Oh yeah, yeah. Yeah, HN is doing it. Yeah.
So what about like adding these people now? Do we add them?
No, no. Just put the link in the WhatsApp group. That's all. They can just join as
Yeah,
guests.
yeah, that's fine.
Please.
Hi guys, welcome to the first session hosted by Programming Club. So let's have a warm intro. Am I audible? Anyone could confirm?
Yeah,
Yes, you're
you're
audible.
audible.
So yes, this is the first session of the Dev Camp, and I'm Preenal Kumat, Programming Club project member. I'll be hosting the session for you. So yeah, next slide. So guys, how many of you are very enthused about coding? Please put a very good emoji. Very, very enthused about programming. Like that's the only thing you want to do. So yes, but why? It essentially is everything. What do you like? Yeah, why? Because it essentially is involved in every sector you want to go in, right? Because any sector you want to go in, it's driven by code right now. Any new technology you want to go in, yeah, it has to be something, some software, something of that sort, right? So that's why we here as a programming club are hosting this session. So actually, we can validate this by a problem. Next slide. Yeah, that's one of the great reasons, money. So right, like, okay, yeah, most of us are J aspirants, right? So we have heard of this problem, right? There's a pool of length L, two swimmers are planning to swim. They start together in different lanes, like right, one with speed V, another with 2V. After reaching the other end, they again turn back and start swimming back to point zero, right? Let's say they meet at some point T and find that. Like this was a very basic problem we solved. But what if n increases or t becomes large? The complexity of this calculation increases, right? Next slide. This is when coding comes into picture, right? Because next, yeah, this is when coding comes into picture. So basically, what it does to us is it facilitates automation. It actually gives us better efficiency. It reduces complexity. It makes the solution scalable, and it's a very important tool for data management these days, right? So whether you want to pursue any sector, anything, programming is the essential skill you want to learn, right? So here, CFI and Programming Club is hosting this so that you learn about software development. Next slide. Yeah. Next slide. Yeah, so we're hosting this so that you learn more about software development. What we'll be covering broadly in the are like pointers, heaps, stacks, the basic memory management techniques, concepts of OOP, and concepts of OOP like classes, objects, functions, constructors, operators, more about them because they are very important for the modular design of your software. Next slide. Next slide. And most importantly, file management techniques, which are very essential in any field you go. So yeah, guys, let's start with the first session. And our first topic is going to be pointers. Next slide. So what essentially are pointers, right? Pointers are something like, these are derived data types that can store the address of a variable. What do you mean by the address? They can store the memory location of the variable. We can access and manipulate the data stored in that memory location using that pointers. So basically, guys, so do you all know about variables? What are they? Anyone, if they could just write, what are variables? Okay, right. So basically, yeah, anything. Yes. Great. So you guys know about variables. So what do you do is when you have a system, when a variable is stored, it is stored in some memory location, and the address to that memory location is contained in that pointer. If you want to assign that, if you want to know that point, so basically if you have a variable named p which stores a character c, the memory location of this address you can find out by assigning a pointer, that is char star pointer is address of c. Okay, the syntax of it goes as data type asterisk pointer. Asterisk is the dereferencing operator here. Okay, so pointer holds the address of C and at is the address of operator. Everyone clear? So basically a variable of type T star can hold address of type T. Okay, guys, so basically if you have a variable named p with a value 10, suppose for example, which is stored in some address, something like that, you can define a pointer which stores the address of this, and you can the syntax for this will be the data type asterisk the name of the pointer which is assigned to that address of c. Okay, let's go in detail. So when you have a data type, you have 3 steps, right? You have what you have to do is declaration, initialization, and any changes you want to make, right? And, basically accessing that variable. So pointer declaration is of the type data type star and pointer name. Guys, basically it's of the type data type and name, right? Is it clear right now? This is the proper declaration format. And when you want to assign it, so basically when you declare a variable, it gets some random. Okay, is there a lag? Okay, right. I don't think so. There's anything from our end. Okay, right. So basically, you have 3 stages. Once declaration, initialization, and then accessing that variable, right? So declaration is data type, asterisk, and the pointer name, right? So that's how you declare a variable. And then if you want to initialize it to some data type's address, what you do is data type star and the pointer name, and you assign it to that address of variable. So maybe that's clear right now. Next slide. Next slide. Next slide. Yeah. So basically, how do pointers work? So now you have a variable named 10, which is at some address 2022, something like that. And if you have a pointer which goes to the address of that variable, you can access that value using asterisk pointer, which will lead you to the value of that variable. That's how values are addressed, which is exactly which is being done here. So you have int variable is equal to 10. You have int star pointer, which points you to the address of that variable. You can address that value using dereferencing operator, that is star pointer. You change it to 20. Now the value which is stored in that variable is 20 and not 10. Okay, do you guys want to do a program which proves this? Right, so next slide. Oh, we're using C++, right? So yeah, so basically, So this is the program where we have a character C, which is given a value A, and character P, which stores, which is equivalent to C. So basically now we have a pointer, which is we have char star pointer. See, this is the declaration statement, char star pointer, which is declaring a pointer, which is the address to a character. Guys, I guess there's a lag from your end then. Okay, so basically, you have a pointer which stores the address to that character, or pointer which stores address to character C. So basically, if you want to find the address of C, how do you do that? Yeah. So guys, basically, if you have the address of C, which is something like 0x12456, something like that, if you type add C, it gives you that value. The value is the value which C stores is A, right? So if you print that in the second statement, it gives you that. The value stored in the pointer is the address of C. Do you guys get it? Right. Basically, pointer stores the address of variable C, right? The address of variable C, you print it using add C. The value stored in C is C, and the value stored in pointer is the address of C, and the value stored at the address stored in pointer, you find it using the dereferencing operator. That is asterisk pointer. Guys, does anyone want to predict the output of this program? Just mention the values which it will give as an output. The address of C, the value stored in C, the value stored in pointer, and the value at the address stored in pointer. Oh, that's a double pointer. That means address of the address, yeah. Guys, does anyone want to predict the output of this program? Yeah, just try, because so basically first is address at C, which is the value stored in C, the value stored in pointer, and value stored at the address stored in pointer. Yeah, great. So great. Next slide. So basically, the address of C at C gives you this address. Value in C is A, which we initialize that as. The value stored in pointer is the address of C, which is exactly the same, and the value stored at the address stored in pointer is A, which we found out using the dereferencing operator. Right? That's clear. So yeah. So anyone, so basically, did you guys understand the three stages of a pointer? Declaration, initialization, and dereferencing. Declaration is when you say that this variable will contain a pointer, which will be data type asterisk pointer name, right? Initialization will be when you assign that pointer some address, right? Basically, if it's an int data type, you assign it like int star pointer is equal to address of some int variable, right? And dereferencing is when you try to access the value which is stored at that, when you try to access the value which is stored at that address. So guys, I have a simple problem statement for you, right? So what you guys need to do is write a simple program that creates an integer variable with initial value 5, assign A's address to be B and change the value of A to 15 using B. Whoa, that was swift. So great. Just give it a try. Like actually trying out helps a lot. You understand better. Yeah, guys, so everyone's clear with this program. Are the basic concepts clear, right? Declaration, initialization, and dereferencing. How you access that value using pointers. And the pointers, you can have the basic operations done using pointers. So basically, if you want to change that value, you can use asterisk B and put it as 15. And then the value stored in A will not be 5, it will be 15, right? Do you guys get this point? Yeah, right. So basically, what you need to do is here have a variable which is assigned a value 5. Yeah. So I guess yeah, A is addressed to be B. So basically, you have B, which is a pointer variable to A. So you have int star B, which will be equal to address of A. And then you change the value of A to 15. So basically, what you need to do is use dereferencing operator, point asterisk B is equal to 15. What dereferencing operator does is it takes you to the value at that memory location, right? So basically that value would be changed to 15. And now if you print the value of A, it will not give you 5, it will give you 15, right?
Brilliant. Let me just code it up and show it, right? Maybe that would help
Okay.
people. So hey guys, this is basically going to be trying to code up whatever was the question. So initially we had this variable A, which is set to value 5. So any variable, if you have any variable which is running in the program, it should exist somewhere, right? So 5 should exist somewhere on the computer. So it is stored at a specific memory location. And to be able to access this memory location, we use something called a pointer. So this kind of is the syntax of how to do it. I'm just recapping it a bit. For some of them, I feel some of them were lost in between, so I'll recap it. So this is the syntax of trying to find out what the memory location where A was stored at. So A is stored at somewhere in memory in the computer, and finding out the memory location is done using this int star asterisk symbol. Basically says that this is a pointer of whatever type is to the left of it. So if A was a float, I would call this would be something like float star. Here is int, so it's int star. Whatever is to the left of this asterisk symbol, that's the type of the pointer. Like that's the data type the pointer points to. This ampersand operator helps you find the memory location of A. So this is basically like
Naveen, 1 second. Your screen is not visible, like the left part. I guess since you have split it, people can't see the entire thing. I guess zoom out a bit or zoom in. Like they can't see what's written to the left of and percent and stuff.
I'll just share the entire screen. Is it fine now?
Yeah,
Sean, is
yeah,
it fine
it's
now?
fine.
No,
It's
yeah,
fine.
it's
Yeah,
better.
It's fine.
okay.
It's fine.
It's great. So yeah, I'll just recap. A is a variable it exists somewhere in the memory. We want to find the address where it exists. It will help us in the future. Believe me, it's probably one of the most helpful things out there.
Sorry to pause, but can you just increase the font size?
Yeah, sure. That's fine. This is fine.
Yeah, it's better.
Yeah, pointer is the address where A exists. And instead of directly changing A to 3 or A to 15, a hacky way of doing it is going to a memory address and trying to change A to 15. How do you access whatever is at this memory address? PTR is where it's located. How do you change where it's located? Use something. You again use asterisk, which doubles as something called a dereferencing operator. Asterisk PTR means you're trying to dereference. You're trying to find out what is the value stored at that memory address. You find out that value and you assign it to 15. So that's basically what we are doing. That's what was asked to, and yeah, that's a brief explanation of the code and how to solve this problem. Prinal, back to you. You can continue with it, I guess. Yeah, thank you, Prinal.
Okay, so next slide. Thank you.
One minute.
So the next slide.
Yes. Slides are visible, right?
Yeah.
Yeah, it's visible.
Yeah, right. So what all can a pointer point to, right? We dealt with int right now. So if you want a pointer which can point to an int and in a variable which is storing an int value, you use int star pointer. If it would have been a float data type, as Ajichan said, it will be float star pointer and like that. So basically, it can point to all kind of these types: int, float, double, char, and all. It can also point to arrays. So basically, if you want to point to an array, what you use is char star pointer, and at the address of that array. If it can also point to non-primitive data types or structures. What you can do is struct name, and you use the pointer name, right? It can point to functions, and it can also have null as its value. Next slide. So why do we use pointers? So basically, it's mostly used when the size of the when you want a dynamic memory location, when you don't know the size of the variable or the object data type which you want. What it does, it allocates some memory for it, and it will most probably be very useful when you're using heaps and all. So when you want to use dynamic memory allocation, you use pointers. And basically, okay, guys, I have a problem statement for you. What is the size? As we all know, do you guys know the size of int variable? Guys, size of int. Yeah, right. So basically, can anyone predict the size of a pointer variable? Guys, is everyone aware of the size of operator? You can just try it out. Right. So basically, it's the pointer variable is a fixed size. If you have an array, also it will have the same size, and if you have an int, also it will have the same size. So basically, it depends on your hardware. And so basically, when your most machines work directly, so basically most machines can accept only a certain amount of size. So pointers are your go-to option there, because you're only giving that amount of size as an input, right? So when you have size issues, pointers are your go-to option. Yeah, next slide. Yes, so I have a task for you. You can complete this before the next lecture. You can take a screenshot and complete this problem statement before the next lecture. What you essentially need to do is variable swapping using pointers, and you can go through it. So what you need to do is define a function named swap that takes two integers and takes two pointers as parameters. Inside the swap function, yes, repeat. Okay, basically pointers are of fixed size. If you store an int or an integer array, it will always be of a fixed size. It depends on the your processor. It can be of 4 or 8. Right. So so the task is you're required to write a program that swaps the values of two variables using pointers. And so basically you have a function named swap, which takes in two pointers as your parameters and swaps their values. And you just need to implement this and then display, first display the values before swapping and then display the values after swapping. So this is one of the tasks. Yeah. It will be posted in the, right. So just try it out, give it a shot. Oh, you can have this solution in the, do you have this next slide? Right. So this is briefly the solution, how you need to proceed. You have a swap function which swaps the values for for A and B. And so this is a swap function and you just show the values before swapping and after swapping, right? Next slide. Void is basically when you when the function doesn't return any value, so you use void there. So yeah, can you go to stacks directly pointers? Yeah. So yes, guys, is everyone clear with pointers? We can move to the next thing in our course, which is stack. Yeah, that's what you need to do. You declare a dummy temp variable and yeah. So basically stack. Right, guys, good to move. Guys, please react if you're good with pointers. Yeah, great. So guys, can everyone type the address of operator? Yeah, just react with address of operator if you guys remember. Yeah, great. So guys, let's move on to stack. Stack is basically a data. Okay, guys, do you know about data structures? If data is stored, it has to be stored in some format, right? And stack is one of the memory management techniques which is used. It is a technique where, okay, guys, imagine a pile of plates. Like if there are plates, you stack it one above the other, right? If you want to, so which is the place which is always accessible to you? If you want to take a plate, which plate would you take out? Top one. If you want to add a plate, where would you add? To the top one, right? That's what basically stack is. Next slide. Next slide. So basically stack follows the last in first out principle. The strategy states that the element that is inserted last will come out first. So okay guys, do you all know about arrays? Yeah. So yeah, so in arrays you can access any element, right? But stack is a data structure just like arrays which stores many values, but what is accessible to you is only the top value, right? So if you want to add a value, it has to be added on the top of the list. And if you want to remove a value, it has to be the top item. You can't access anything in between, right? So that's called last in first on principle, life, right? Next slide. So basic operations on stack. You have some basic operations. What do you call them? As push is when you insert an element to the stack. Okay, guys, where would that element be inserted again? It's a stack. If you want to push an element to the stack, if it's if it's an array or if it's a fifth element which is already there, which element would next be inserted? Like which would it be? That what number would it have? 6. Great. So yes, push is when you insert that element to the top. Pop is removing that element to the top. Okay, guys. Pop is if you have now you have 6 plates, right? Now if you want to remove one plate, so which one will you remove? 1, 2, 3, 4, 5, 6. Which one will it? Again 6th, right? So that's what stack is. So top returns, okay, the top function. Now we move to the top function. It returns the top element of the stack without removing it. So top function tells you that which element is at the top. So if you will remove something, which element would it be? That's the top function. Is empty returns if so basically it's a Boolean function which returns true if the stack is empty. Otherwise it says false, right? No, you can't. That's stack, right? You can only access the element on the top. Pop can't be used to remove any element in between, right? Size returns the size of the stack, right? Okay. Next slide. Next slide. Right. So basically, one of the great examples of implementation of stack is function call statements. Guys, we can see here's a simple function which is adding two variables. So basically, you have add function which takes in two inputs, x and y, and returns the sum of x and y. And there's a main function which has sum, which has a, b, and it calls add function and it prints out sum, right? Does everyone get the basic overview of this program? Right. So basically, how is stack implemented here? When your program starts, you always start in the main function, right? So that main function is the bottommost part where you have a, b, sum. Guys, does everyone know about the scope of variables? Like if a variable is declared in a certain scope, it's only accessible to them. Like since a is declared in between those brackets, you can only access the value of a in between those brackets, right? That's for local variable. We also have global variables, but we're not using it here. So yes, right. So basically, when you call function statement in that environment, when you have main function in that environment, you have a, you have b, and you have sum as your variables there, right? So that's your first layer. When you call a function, when you call add function, you have to give two values which you're giving is a and b. But when your add function starts, it's basically a layer above it, and now you can't access a and b. Like if you type in add function, if you try to print a, it will show that you don't have a variable a, right? So a can't be accessed from add function. It can only access the parameters pass. So right, in your add function you have x and y, so that's stacked above it. Now when it returns, so basically you're popping that add function out, and then you'll again return to main. So this is one of the implementation of stack function. You can't change the memory order. That basically means from add function, you can't access the variable stored in main function, right? Is everyone getting it? Guys, yeah. So basically what happens here is you start with your main function, you have sum a and b, and a function which you call to add a and b, and then you print out sum, right? In that stack, you have a main function, a, b, and sum. You call add function, it's a layer above it. You have x and y there. You can't access a and b here, right? When you return back, you're again popping add out. You return back to that main function, and then you again have a, b, and sum. Yeah. Right. So so basically you can't change the order of memory. That's basically stack. Next slide. Right. So we saw one of the applications, that is function call, recursion statements, undo redo operations, browser history, all use these kind of structures, and that's where stack is applied. Next slide. Yeah, guys. So okay, guys, one of the main important point is stack has a finite size. So if a program exceeds its available stack space, a stack overflow occurs. So basically what it means is you have a rack which can only store 10 dishes. If you try to put the 11th dish, it won't accept, right? That's how stack works. Now, if you have an infinite loop or something is like that, what happens is you just go on stacking of functions and functions and functions, and the memory is full. That's why you're not able to execute those kind of programs. That's when stack overflow occurs. Memory is full, and yeah, you're not able to store things then. Guys, did everyone understand this? Right. Great. So yes, so stack is something where you define the size which has a predefined size, right? So it can, like, suppose take only 10 variables. So yeah, the 11th variable won't be there, right? Now heaps is something which is dynamic memory allocation, like where the memory is allocated during runtime as needed. It is useful when the size of data structures is not known. Have you guys heard about dynamic arrays and all? Right. Okay. Yes. So yeah, so basically it's something where the size is not defined. Like when you define an array, usually it's where you define as it can store like 10 integers or something like that. But if you don't do it, okay, guys, I don't think so we need to go there. But so basically anything where the size can be specified during runtime is called dynamic memory allocation, right? Which is basically heaps. We'll see that in the coming slides. So next slide. So yeah, so you have a simple program where you see that okay, guys, int a is equal to 10. Is it, what does it use? It uses stack type or heap type, if anyone can answer. What type of memory allocation does it use? Right? Yeah, so basically int has a predefined size, so that uses stack allocation. Now when you go to p, so when you see, like, the syntax, it is data type star p. This is pointer syntax, which gives a new int variable. This is dynamic heap memory allocation. And right, so this is the heap type when the memory has to be allocated during runtime. Now when you say p as 10, it gives it, so basically an int thing is allocated to it. That's the int size. And you need to delete p also. So basically the heap has to be constructed manually and deleted manually, whereas stack does it on its own. Like when the scope ends, it automatically gets deleted, right? Oh, new int is so basically heap has a declaration syntax, which is data type star, the name is equal to new data type brackets. That's the declaration syntax of heap. Yeah, right. So yes, next slide. as we can see, right. So basically okay, so yeah, we're going to the operators. So memory allocation is the new operator. New operator is used to allocate memory for an object in the heap and construct an object. So it performs two operations, that is allocation, that is the new operator allocates memory of appropriate size for that object, and object construction, that is new operator invokes the constructor for that object so that it can get initialized and it has some initial value, right? So the syntax, okay, right. New operator is basically memory allocation operator. Like basically you're reserving some memory space for that variable, right? So you're basically saying that, yeah, this variable, when it gets, it will reserve some space, and then, yeah, like malloc in C. Right. So basically the new operator allocates memory of appropriate size for the object being created, right? And on initializing it invokes the constructor and initializes the object. So right, so basically object type star pointer is equal to new object type and into the and the arguments passed. Okay, right. We're just going to examples. So right, if you want to create a heap kind of structure for int, so basically if you want an array of size 10 using heap, right? So if you want the one of the examples is data. So what you need to do is data type star pointer is equal to new data type into the arguments. Like if you have an int variable, you don't give any argument. That's basically the default case. If you want to assign an array of size n, suppose, so what you do is data type asterisk pointer is equal to new data type. That's what new operator does. It allocates some space for that variable, and if you have some arguments, it allocates that much space. Right? Okay, guys, let's have a quick question. Memory allocation in the stack follows last in first out principle. Is it true or false? Guys, let's have a quick recap. So right. So yeah. So basically, yeah, this is what stack was, last in first out principle. If you guys remember, that was just to refresh you guys if you guys are getting confused with heap. So yeah. So what new operator does is it allocates some space in that memory, and if it's initialized, it initializes that value. And the syntax used is data type star pointer is equal to new data type and the brackets which takes the argument, right? Next slide. Next slide. Yeah. So what? So see, in stack, what happened was, as the scope of that variable ends, that space is automatically cleared. But this is not the case with heap. Heaps require explicit memory management. Like unlike stacks, like basically you need to use a delete operator so that you can delete that pointer, right? Guys, is everyone getting it? See, what happened in stack is as soon as the scope of that variable ends, you could no longer access it, right? This doesn't happen in heap. You need to deallocate that memory, like you need to destroy it. So that it is inaccessible to the next functions and all, with the security of the code, right? And this memory management too. So you need to use a delete operator to free the memory associated with that object. The syntax is delete pointer. So basically, if you have a pointer named PTR, so you just write delete PTR and it frees that memory out of that. It happened in scope also, but it happened automatically. You didn't have to do it. As soon as the scope ends, that variable is out of your region, right? So basically, you couldn't access it. But in heaps, you need to explicitly delete that operator. Next slide. Next slide. Yeah. So yeah, this is the case when we forget to delete pointers and all. So yeah, in heaps, the memory has to be explicitly managed, like where you don't require those pointers and all, you need to delete them. And like if too many pointers are allocated, heap fragmentation can occur, inefficient use of memory, right? It can lead to many other errors. So what you need to do is timely delete those pointers so that you have a very efficient code running. Guys, is there? Guys, is there a lag? No, right?
There's no lag.
Yeah.
No lag.
Yeah. So, right. So this is when memory leaks can occur, right? Next, so we have a small question. In which memory region are local variables and function call information stored? Now you know both heaps and stacks. So where are the local variables and function call information stored? Stacks, heaps, cache, or registers? Yeah. Is everyone clear with this concept, right? Mhm. Great, great. So next slide. Yeah. So yeah. So basically, we visited both stacks and heaps. And briefly, the comparison. Okay, just we can just go through that comparison. So in stack, the size of the memory to be allocated is to be known, like to the compiler, whenever a function is called. Like you need to know the size before that. And heap is dynamic memory allocation, as we all know. Stack is whenever the function call is over, it automatically deallocates. Heap, you require manual deallocation using delete operator. And stack is considered safer because you don't need to like the program does it for you. It ends the scope and all. And heap may you have the scope of making errors. So yeah, if you forget deleting that pointers, it might be unsafe for your program. And yeah, so that's what basically stack and heap are. Any doubts in the basic concepts of memory management? Yeah, are you guys clear? Just react with an emoji. Yeah. Okay, yeah. So yeah, guys, let's so next slide. Let's move on to the next slide then. Right. So this question might make it more clear. And see, this question is a simple program where you have a1 variable, which is given a value 10. You have a pointer p1, which okay, I don't think so. I should say the answers before. So guys, just see the program and see the questions for a minute. Right. So we visited stacks and heaps. So right. What do you think? Which variable has stack memory? You have A1, P1, and P2, right? Guys, is everyone clear? A1 has stack memory because it is an integer data type with like fixed size. Yeah. So which variable has stack memory? It's A1. On which line does the scope of A1 end? Right? See, guys, yeah, the scope of A1 ends on line 11. So guys, is everyone clear? Because it's a local variable, it starts with that bracket, it ends into that. It ends with that. Guys, right. So on which line does the scope of P1 end? Okay, guys, which is the is everyone clear that it ends on line 7? Because it is being explicitly deleted, right? That's what we did, right? In star P1 is new and we allocated some memory. we assigned some value to that pointer and we deleted it in that next line, right? So the scope ends then and there. Is everyone clear with that concept right now, like here? Yeah. And guys, how many dynamic memory allocations like do we have? Like, which variables are those? Yeah. So yes, we have P1 and P2, both of which use heap kind of structures. So right, P1 scope ends on line 7. What about P2? So is this program safe? Yeah. So basically you understood, right? P2 had to be deleted and it wasn't. So that's why it is not not safe. So when you declare a pointer in heap memory, like when you declare something in heap space, you need to delete it explicitly. Otherwise, it is unsafe for your code. So everyone gets that point? Is everyone clear right now? Oh, basically int star P2 new int 4. So it allocates the memory used for 4 ints. It basically means an int array of size 4. And if you remember, we had it in the new function slides. It was the arguments passed. So 4 is an argument here. Right? So guys, did everyone get the answers? Yeah. Next slide. Yeah, so basically we have one more question coming up. Which function or operator is commonly used for memory allocation on the heap in C++? For heap memory allocation. Okay, yeah. So you have, yeah, right, you have new operator, right? So yeah, so we're clear with the basic concepts and this is a glimpse of the architecture used. And now we're open for doubts. Any doubt? So we're done with the technical part today.
Yeah, I think that's kind of what we plan to cover for today. I understand that it might started a bit high off. Okay. Yeah, we'll come to doubts in just a few minutes, but I just wanted to say we probably expected us a small bit of understanding of C or C++ for this session because we have, I guess, 9 sessions and 1 hour of each session. So, and a lot of topics to cover. So yes, really sorry about the bar for the first session. Yeah, you can just post the doubts in the group and we'll try looking into it. Doubts in the chat over here. The groups also work. Can we get the slides? All the slides will be uploaded. You don't have to worry about it.
Guys, I understand this was a little, intense for beginners, but don't worry. As I mentioned in the group, what we'll be doing is we'll be sharing some reading resources with you guys, okay? So that, you can even understand what happened today in case you missed out on some points. And at the same time, you can, cover up for the future topics as well. So if you didn't understand things or if you haven't learned anything about, C or something, we will try to share some resources. It shouldn't take, more than a day or say 2 days before the coming session for you to grasp all these topics. So give us today. We'll share those topics of some reading resources by say 9 o'clock or something. And these slides will be available to you. So make sure that you understand the contents of the slides later And the group is free for chatting. Okay, anytime you want, you can just ping in your doubts, and our team will be more than happy to answer all of them. Um, and today's session, was a little heavy because we wanted to cover things like stacks and heaps. This is just for your understanding. You actually need not go into very depth of these, but I hope you have a very rough understanding of what stacks are, what heaps, and what's the difference. That's all for now. We'll be meeting up soon in the next session on Saturday. So see you guys. Bye bye. Just ping in your doubts on the main WhatsApp group, and we'll try to answer off. For attendance, you have to scan a Google form. But since this was the first session, we are not having an attendance today. So
There is a
you
Google form.
guys. Yeah,
For
yeah, there's a
now.
Google form, but
Just
there's no attendance here for today. You can skip it and try to go through the lecture once properly and thoroughly, and it'll help you in the future sessions. Okay, see you guys. Bye bye. Any tasks for today? The since we had a task planned for you, but what I understand today is people actually didn't grasp the topic well, and some are really beginners. So we are pushing the task, for the next session. So please get your doubts clarified for this session and get your contents, get the content clarified. That's your major task. Okay. I see many doubts out there. Just push it out to the main WhatsApp group. We'll answer it off, and that's all. So I hope you kind of enjoyed the session. We'll see you. Bro, can you show the no attendance is not there today, guys. You can skip the attendance today. From Saturday onwards, we'll be having a proper form circulated and so on. Some new people joined us today, so there was some technical issues popping up. But I hope you understood the overall contents. See you guys. Bye bye. If you have any doubts, put it in the main group. See ya.